Hello, curious minds. What if I told you that the universe might have secret passages connecting distant parts of the universe? Today, we're diving into the mysterious and fascinating world of wormholes. Could these cosmic shortcuts be the key to interstellar travel and even time travel? Let's find out together! Imagine a piece of paper folded in half. Now picture a tiny ant trying to get from one side of the paper to the other. It could crawl all the way across the flat surface, or it could take a shortcut, burrow a hole straight through the fold. That, my friends, is a simple analogy for a wormhole. In the vast expanse of space-time, a wormhole is like a cosmic shortcut, a tunnel connecting two distant points. Instead of traveling through the conventional fabric of space-time, which is limited by the speed of light, a wormhole could theoretically allow for instantaneous travel between those points. Imagine the possibilities. Journeys that would normally take millions of years could be accomplished in the blink of an eye. Of course, this is just an analogy, and the reality of wormholes, if they exist, is far more complex. To understand them better, we need to dive into the realm of Einstein's theory of general relativity. Our story begins in 1915 when Albert Einstein unveiled his groundbreaking theory of general relativity. This revolutionary theory redefined gravity, not as a force, but as a curvature of space-time caused by the presence of mass and energy. Now imagine a massive object, like a star, warping the fabric of space-time around it. Einstein and his colleague Nathan Rosen realized that, according to their equations, it was theoretically possible for this warped space-time to fold in on itself, creating a tunnel-like connection. This theoretical construct became known as an Einstein-Rosen bridge, or what we now call a wormhole. At first, wormholes were considered mere mathematical curiosities, a byproduct of Einstein's equations rather than actual physical phenomena. However, as physicists delved deeper into the implications of general relativity, the possibility of wormholes began to capture the imagination. Over the decades, physicists like Kip Thorne and Stephen Hawking have explored the theoretical framework of wormholes, proposing various models and exploring their potential properties and limitations. These brilliant minds have grappled with the mind-bending mathematics and physics involved, pushing the boundaries of our understanding of the universe. The journey from a mathematical concept to a potential reality is a long and winding one, fraught with theoretical hurdles and experimental challenges. But the allure of wormholes continues to drive scientific inquiry, pushing us closer to unraveling the mysteries of the cosmos. To truly grasp the concept of wormholes, we must venture into the realm of Einstein's theory of general relativity. Now, I know equations aren't everyone's cup of tea, but trust me, the concepts are truly mind-blowing. Imagine space-time as a giant trampoline. If you place a bowling ball on the trampoline, it creates a dip, a curvature in the fabric. That is how gravity works according to Einstein. Massive objects warp the fabric of space-time around them. Now imagine two bowling balls on the trampoline, creating two separate dips. What if those dips were to connect, forming a tunnel between them? That, in essence, is a wormhole. It's a shortcut through the fabric of space-time created by the extreme curvature of gravity. But here's the catch. According to general relativity, creating such extreme curvature would require an immense amount of energy, far beyond anything we can currently generate. We're talking about the gravitational pull of black holes or even more exotic objects. And that's not all. To keep a wormhole stable and prevent it from collapsing in on itself, we'd need something even more bizarre, exotic matter. This hypothetical form of matter would possess negative mass and energy density, essentially pushing space-time outward instead of pulling it inward. The mathematics of general relativity allows for the possibility of wormholes, but the physical requirements are mind-boggling. It's like trying to build a skyscraper out of cotton candy. The laws of physics seem to conspire against us. Now, let's indulge in a little science fiction, shall we? Imagine stepping into a spacecraft, setting a course for a distant star system, and entering a wormhole. The universe outside your window would distort, stars would streak by, and in an instant, you'd emerge on the other side millions of light years from where you started. The idea of traversable wormholes we could actually travel through, is incredibly alluring. But could such a thing actually exist? The answer, my friends, is a resounding maybe. You see, even if we could create or find a wormhole, ensuring its stability and traversability presents a whole new set of challenges. First and foremost, we'd need to contend with the immense gravitational forces at play. Imagine the tidal forces near a black hole, stretching and squeezing everything in their path. A wormhole would likely possess similar forces, potentially ripping apart anything that dared to enter. Then there's the issue of exotic matter. As we discussed earlier, this hypothetical form of matter with negative mass and energy density would be crucial for keeping a wormhole open and preventing it from collapsing. The problem is, we've never observed exotic matter, and its existence remains purely theoretical. And let's not forget the potential for time paradoxes. If wormholes could connect distant points in space-time, they might also allow for time travel, potentially violating causality and creating all sorts of mind-bending paradoxes. So while the idea of traversing a wormhole is tantalizing, the reality is that the scientific hurdles are immense, perhaps even insurmountable. But hey, that's the beauty of science, right? The universe is full of surprises, and who knows what the future holds. Now, as with any extraordinary claim in science, the existence of wormholes has been met with a healthy dose of skepticism, and rightfully so. Extraordinary claims require extraordinary evidence, as the saying goes. Critics of wormhole theory often point to the lack of observational evidence. We've never directly observed a wormhole, and there's no concrete evidence to suggest they exist beyond the theoretical realm. Another point of contention is the requirement for exotic matter. As we've discussed, maintaining a stable and traversable wormhole would likely require this hypothetical form of matter with negative mass and energy density. However, exotic matter remains purely theoretical, and its existence violates some of our current understanding of physics. Some physicists argue that even if wormholes could exist, they would be incredibly unstable, prone to collapsing faster than the blink of an eye. Imagine trying to hold open a portal made of soap bubbles. It's a fragile and fleeting thing. Then there's the issue of time travel paradoxes. If wormholes could connect distant points in space-time, they might also allow for time travel, potentially violating causality and creating all sorts of logical inconsistencies. The skepticism surrounding wormholes is not a dismissal of the idea, but rather a call for more research, more evidence, and a deeper understanding of the fundamental laws of physics. Let's, for a moment, cast aside our skepticism and indulge in a little cosmic speculation. What if wormholes do exist? What implications might they hold for our understanding of the universe and our place within it? The most obvious implication is, of course, interstellar travel. Imagine traversing the vast distances between stars and galaxies in the blink of an eye, opening up new frontiers of exploration and expanding our reach into the cosmos. We could visit distant star systems, study alien worlds, and perhaps even encounter other intelligent life. But the implications go far beyond just space travel. Wormholes could revolutionize communication, allowing for instantaneous transmission of information across vast distances. Imagine communicating with a probe on a distant planet in real time, or receiving data from a telescope orbiting a black hole without any delay. Wormholes could also provide insights into the nature of spacetime itself. By studying their properties, we could gain a deeper understanding of gravity, the fabric of the universe, and perhaps even the nature of reality itself. It's like having a peek behind the cosmic curtain, a glimpse into the fundamental workings of existence. And then there's the mind-boggling possibility of time travel. If wormholes could connect different points in time as well as space, they might allow us to journey into the past or future. Imagine witnessing historical events firsthand, or catching a glimpse of what the future holds. Of course, these are all hypothetical scenarios, but they highlight the profound implications that wormholes could have on our understanding of the universe and our place within it. The possibilities are as vast and mysterious as the cosmos itself. So, where do we go from here? Despite the theoretical challenges and lack of direct evidence, the study of wormholes continues to captivate physicists and astronomers worldwide. Researchers are actively exploring various aspects of wormhole theory, seeking to refine our understanding and explore potential avenues for detection or even creation. One area of active research is the search for indirect evidence of wormholes. While we haven't directly observed a wormhole, some physicists believe that their presence could leave detectable traces in the fabric of spacetime. For example, the gravitational lensing of light around a wormhole might exhibit unique patterns that could distinguish it from other massive objects. Another promising avenue of research involves simulating wormholes using quantum computers. These powerful machines, still in their infancy, have the potential to simulate complex physical systems, including the extreme conditions near a black hole or within a wormhole. By simulating these environments, researchers hope to gain a better understanding of wormhole dynamics and stability. There's also ongoing research into exotic matter, the hypothetical substance with negative mass and energy density that would be crucial for stabilizing a traversable wormhole. While we haven't yet observed exotic matter, some physicists believe that it might be created in the extreme conditions of the early universe or within particle accelerators. The search for wormholes is a long shot, a cosmic needle in a haystack, but the potential payoff is immense. Discovering or creating a traversable wormhole would revolutionize our understanding of the universe and open up a realm of possibilities beyond our wildest dreams. As we conclude our exploration of wormholes, we're left with more questions than answers. Are these cosmic shortcuts merely figments of our imagination, or do they lurk out there in the vast expanse of the universe waiting to be discovered? The truth is, we don't know. The existence of wormholes remains purely theoretical, a tantalizing possibility allowed by the laws of physics but yet to be confirmed by observation or experiment. But that's the beauty of science, isn't it? The search for wormholes, even if it ultimately proves fruitless, will undoubtedly lead to new discoveries, new technologies, and a deeper understanding of the cosmos and our place within it. Perhaps one day we'll develop the technology to detect or even create wormholes, opening up a new era of interstellar travel and exploration. Or perhaps wormholes will remain forever out of reach, a tantalizing what if that fuels our imaginations and inspires us to explore the universe around us. Whatever the future holds, one thing is certain: the universe is full of surprises. And there you have it. We've journeyed through the fascinating concept of wormholes, explored their potential, and considered the challenges. Are wormholes the key to interstellar travel, or will they remain a theoretical curiosity? Only time will tell. What do you think? Do you believe we'll ever discover or create a traversable wormhole? Let me know your thoughts in the comments below. If you enjoyed this video, don't forget to give it a thumbs up, share it with your friends, and subscribe for more intriguing explorations of the universe. Until next time, keep looking up.